Welcome back, fourth grade teachers. Today we are going to dive into Module 3. In this module, we will focus on numerical reasoning. We will cover what it means and dig in a little deeper to standard NR1. Just a reminder, over the next 2 years, we will be continuing to learn and grow as educators as we deepen our knowledge of these new standards. Implementation will not occur until the 2023-2024 school year. As we continue to learn about these new standards, keep in mind that in order for deeper learning to occur, we must shift our mindset as educators. Our goal is to create creative and critical thinkers in mathematics. Please review the mathematical modeling frameworks. This framework shows that learning is a cycle, not just a linear path. So, what's the big idea of numerical reasoning? Well, it's going to be replacing many of our current number and base 10 standards. The emphasis is still going to be on place value, rounding, comparison with multi-digit numbers, addition, subtraction, multiplicative comparison, and multiplication and division involving whole numbers. But there is a shift in our mindset. We are going from the rote memorization of skills to a conceptual understanding, which is why reasoning is part of the standard title. Students should be able to explain how and why they are getting their answers, not just memorizing steps in a process to get there. Take note of the learning progression chart. It gives a strong overview of the expectations from one grade level to the next. This will help with vertical alignment of standards. As you can see with place values, students are going from reading and writing numbers in the thousands place in third grade to hundred thousands place in fourth grade to finally in fifth grade incorporating decimals to the thousands. Personally, this is going to help me when planning units because I'm going to have a good idea of what my students should have learned in their prior grade level. It's going to be more clearly outlined than anything we've really had in the past. Now, let's get down to the nitty-gritty, what we're all here for. Standard 1 for numerical reasoning, or NR1. It is recognized patterns within the base 10 place value system with quantities presented in real-life situations to compare and round multi-digit numbers through the hundred thousands place. This standard is going to be broken into substandards that are now called expectations. We are going to look at all 4 expectations for NR1 today. But before we do that, I want to go back to a word or a phrase that's very, very important in this standard, real life situations. The goal with these new standards is to teach math in an authentic way. We want students to make connections to how they will use this math in the real world or in their real life. Before we dig into the expectations, let's take a minute to look at the standards chart. In the green section, you will see the overarching standard. So this is going to be the main umbrella that's going to encompass all the numerical reasoning standards. Below that, in the blue, you will see the standard we are looking at today, which is recognized patterns within the base 10 place value system with quantities presented in real life situations to compare and round multi-digit whole numbers through the hundred thousands place. Below that, in the kind of orangish color, you're going to see expectations and evidence of student learning. As I've said before, the expectations are basically the substandards, whereas what we've been looking at in the past would be, for example, you would have your standard title and then you might have A, B, C, and D. This is numbered. This is broken down in numbers, so 1, 2, 3, and 4. My favorite part of the new standards is the evidence of student learning. We've said that before in our first 2 modules, but this is the area that you are going to spend the most time in. This is the area that's going to give you the most bang for your buck. All right, let's look at the first part of 4NR1. That is 4NR1.1. Read and write multi-digit whole numbers to the hundred thousands place using base 10 numerals and expanded form. It's really important to note with this standard that students are not expected to write numbers in word form. However, they are going to be expected to write numbers in number form and be able to identify those numbers in expanded form. This is a standard that is pretty self-explanatory. It is them being able to recall and read numbers in a problem. All right, we're going to move on to the second part, or the second expectation of 4NR1. So it's 4NR1.2. Recognize and show that a digit in one place has a value 10 times greater than what it represents in the place to its right, and extend this understanding to determine the value of a digit when it is shifted to the left or right based on the relationship between multiplication and division. This currently is our MBT1 standard. For 4NR1.2, we're going to look at an example. The population of Atlanta is about 500,000, and the population of Valdosta is about 50,000. How many times greater is the population of Atlanta than Valdosta? The goal is to have students be able to look at these numbers and identify that the population of Atlanta is 10 times greater than the population of Valdosta. Questions like this help this standard be taught in a practical and applicable way. The whole idea is to think, how will students see this standard in real life? I also included an image of base 10s because that is a great way to introduce this standard. Students are going to need a concrete understanding of numbers and how they change, and base 10s show a perfect example of what's happening as the digits are moving in a number, particularly when you look at your ones block comparatively to your 10 stick, comparatively to your hundreds flat, to then your thousands cube. All right, we're going to move on to expectation 3. Use place value reasoning to represent, compare, and order multi-digit numbers using the greater than, equal to, and less than symbols to record the results of the comparison. I did note here that that is going to be in numbers less than 1 million. I included 2 different examples here of just comparing numbers. The first number is 47,208 is less than 47,828. The next one I included is 382 is greater than 346. I also included a number line that represented that problem. A number line is a great tool for students to use when they're comparing numbers. They should be able to make a connection that the 8 in the tens place of the number 382 is greater than the 4 in the tens place of 346. When they look at those numbers, they should be able to see the value that the 8 is its value is 80, whereas the 4's value is 40. The connection should be made on the value of each digit in the numbers being compared and ordered. For NR1.4, use place value understanding to round multi-digit whole numbers. Within this 4NR1 standard, this is the only expectation that includes a strategy. That strategy is going to be that students will use a number line to locate numbers to the nearest multiple of 1,000, 10,000, and 100,000. When rounding using a number line, the students need to learn how to first draw a number line. So after that's done, then they can use this strategy with any number up to 1 million. Another thing to note is that the point of this standard is to ditch the tricks and help students learn to reason through mathematical concepts. So no more 4 or less, we go down, or 5 or more, round up. We're not teaching them rhymes, we're teaching them to understand, which is why the shift goes to using a number line to teach this standard. All right, so in our next module, we are going to be covering 4NR2 using part-whole strategies to solve problems including addition and subtraction through the hundred thousands place, as well as multiplication and division of multi-digit whole numbers presented in real-life mathematical situations. We're also going to be looking at our first patterning and algebraic reasoning standard, 4PAR3. Generate and analyze patterns, including those involving shapes, input-output diagrams, factors, multiples, prime numbers, and composite numbers. But before you go today, I wanted to leave you with some resources that are going to be great for these new standards, but also resources that you can use now in your classroom. The first one is Robert Kaplinsky's 3-act tasks. These are great reasoning problems that deal with everything from rounding to multiplication. I also included some digital resources that will give you access to digital base 10 blocks, fraction tiles, and things like that that you can use in your classroom. All right, so the major takeaways today should have been that manipulatives and models create a deep understanding of mathematical concepts being learned, and tricks are not appropriate for teaching lifelong understanding of math. Remember, we want to create mathematicians, not just in 4th grade, but forever, for a lifetime. I've linked here the K-8 new standards, so if you have not already reviewed those, I highly suggest going and looking at them and printing out a copy to refer back to as we continue these modules. All right, but before you go, please do me a favor, and at the end of this module, you're going to be asked to share some research sources that you currently use or have used to teach the standards, or even just a single expectation of the new standard. Remember, we're looking for engaging activities that require critical thinking, so get creative, dig into that Google Drive, and please be sure to not share any copyrighted resources or resources that you've purchased from somewhere. This has to be original resources and original activities. I can't wait to see what you guys submit, because I know it's going to be a ton of great and amazing resources and content that we're all going to be able to use to teach these standards in the future.